Okay, so this one is employee ID. So you not to confuse with this logic. I mean, here we are not writing any logic, we are just checking. The same thing, whatever we discussed earlier, this one, right? If it is greater than with the current one or less than with the current one or equals with the current one. So if it is a positive one result, negative one result equals one result. So the same thing we are doing here. We are checking is greater than or less than or else means obviously it will come to the last part, that is equals part. So we are not explicitly writing that. So greater than, less than, else return 0. So the default sorting order here is, where is the error? This one. Now let me write it outside of that. Okay, or is already outside of that. Okay. Okay, so for the same class, not for the same class. Yep. So we have the default natural sorting order for employee, that is by age. Okay, by age. So I have implemented this custom sorting, but I did not call this. Okay. Now I have added different employee objects. Now if I execute it, what will happen? It will sort based on the default natural sorting order. So what is the default natural sorting order for employee? It will sort based on the age. Now if I run it, if you see, it did not sort based on the employee ID. It is sorting based on the age 2, 11, 12, 34. Now I don't want that default natural sorting order. I want my custom sorting order. So what I will do, I will pass my custom sorting order. Okay. So actually, if you see this tree set, it is having different constructors. One is default constructor, another one is this comparator. Okay, let me show you that. Okay, if you see the different constructors for Treeset, it is having default constructor. Another one is collection. It is taking collection. Another one is comparator. Another one is sorted set. So the Treeset is taking these 4 different constructors. So the collection we have already seen that. Suppose assume that suppose um, you have some list object, okay, that you want to pass to Treeset. So what you can do, you can pass it like this. So what is this? This is passing a collection. So array list is a collection, right? So this is passing a collection object to the Treeset constructor. Whereas here, this is passing comparator object to the Treeset. Okay. So this is not the new that this is this is nothing but it is having different constructors. It is taking comparator object, or it is taking collection object, or it is taking sorted set, and at the same time it is having a default constructor also. So now at this time we are passing comparator object. So because the custom sorting is a class which is implementing comparator. Okay, so now I'm passing that object. So what is happening? It is comparing different objects. Now if I run it, I did not change anything. I just pass my custom comparator. Okay, so now this tree set, what it is doing, because I explicitly converted to the object, sorry, this object I am explicitly converting into the employee. That means that the assumption is all the objects that we are passing to this tree set is employee objects. Okay, and that is another point actually. That is another point. So before saying this, I'll show you that. Okay, so now I have passed some employee objects. Okay, now I'm at the same time I'm passing some number or some string. Okay, now what will happen? It is throwing the class cast exception. Cannot cast string to employee. Okay, so Treeset, but the other day what we are saying, all these collection classes, it is a group of object. Any collection class is a group of objects which will take heterogeneous objects. That means it which will take different type of objects. But that is exceptional for tree set. So tree set is also a group of objects, but it will take only one type of objects at a time. Okay, you cannot mix different objects to the same reference. If you want, we will take another object, and in that object you will just add only the strings, and take another object, you just add only integers. Now here we are already adding employee objects. Now to this reference you need to add only the employee objects. So basically a tree set will not accept different type of objects adding to the same reference. Okay. So that is one thing. Now let's come to our example. So now I'm passing this custom sorting. So now I'm passing only the employee objects to this tree set. So but the employee is already having some default natural sorting order, that is sorting based on age. But what I did to this, while creating the tree set object itself, what I'm saying, take this sorting order. Okay, while creating the tree set object itself, I'm saying that take this sorting order. Now what will happen? So tree set, what it will do, every object that we are adding, it will go with this sorting, not with the default sorting. because while creating object itself, I am saying whatever the object adding to this tree side, do this sorting order. Okay, so now let's see what will happen. Okay, it's just printing only 1. That means our condition is not working. So what we did, yeah, if you see here, for both employee objects, I am passing object 1 only. I am not passing object 2. So since I am passing object 1, always it is returning 0 because it is not greater, it is not less than, it is always 0. So that is the reason it is printing only one object. Now if I execute again, it did not, actual sorting order is, yes, the actual sorting order is, the default actual sorting order is age. But what happened? It is sorting based on the employee ID. Okay. So it is sorting based on the employee ID. So now you will have some idea like why we need a comparator when we have comparable. So comparable, and again you might have a doubt that okay, we are doing custom sorting order, but again why comparator? Yes, comparable is always for natural sorting order, whether it is your user defined class or predefined class, it will have the default natural sorting order. But on top of the default natural sorting order, if you want any extra sorting order, extra custom sorting order, then we'll go for comparator. But the logic is same. So we did not change any logic, right? This logic is same, except that uh, here I am checking condition on employee ID, and there I am checking the condition on age, but the overall condition is same, but we are sorting on a different field. That's it. So comparator is for custom sorting order. Okay. So now we have already seen uh, this one. What is that? Mm, method local inner class, right? So now this is the scenario where we can use method local inner class, because if you see here, I just have only one method, right? I just have only one method. So what I can do, instead of taking a separate class and overriding that compare method, what I can do, I can write itself, I can write that here itself. Okay. Comparator. What is that? Okay. Now I am comparing here itself. I'll write the same logic there. Yeah, we will see this warnings because I did not typecast it with the employee. That is the reason it is showing those warnings. For now, that is fine. So what I did, instead of taking a separate class, so I'm directly passing here. Okay, I'm directly passing anonymous method local inner class. Okay. Now, if I execute it, the result is same. Now, the result is same. It will sort based on the employee ID. Okay, 2, 12, 23, 25. But the natural sorting order is based on the age. But what we customized that sorting based on the employee ID. Okay. Now another thing that what we can do, another way how we can write the same thing. The same thing, comparator with our lambda expression, right? So this is method local inner class. So when we can write our lambda expression for the functional interfaces, right? While when we call an interface as a functional interface, if it is having only one method, okay? So this is having only one method. Of course, that equals method is not from the comparator, it is from the object, okay? So it is having one method. Now if I say comparator equals to say for example employee e comma employee e1 to okay, is expected of type object. Okay. So for each object, we are writing our yeah, this is correct only. Let me typecast it to employee. Hit here employee. Now if I say me dot it, for example, I want it by employee name dot compare to of e1 dot compare to. So this one is ending here. Okay, this is this one. Is also not required. Add to employee name. Okay. So now what I can do, instead of the whole thing here, okay, I'm passing comparator. Okay, so now what I did, I am comparing now this comparator. What I was doing, I was sorting based on the employee ID, but my default sorting order is default sorting order is based on the age. Now here, what I am doing, and one time what I did, I have created a user defined, another class. There I am passing, I am filtering based on the employee ID. But instead of creating a class, separate class, so what I did, and one example, I am passing it as a method local inner class. Now what I did, I am passing a lambda expression, right? So it is taking for each employee, compare with based on the employee name and return the result. So now that is my custom comparator. Now if I pass it, if I execute it, what will happen now? It will sort these objects based on the name. Let's see that. It should not sort based on the age because that is the default natural sorting order. Now I did not sort based on the employee ID. I am sorting based on the employee name. So now it should sort based on the employee name. Okay. C came first, P, R, S. Okay. With this much line of code, method local learner class, we have so much code here, right? And here also we have taken a separate class. We have written this method and we are passing it to the Treeset constructor. But this one, just a one line, right? It's just a one line. So it is also doing the same. Even a separate line, I can write this whole thing here, right? Instead of course, this is a comparator. Instead of writing this one, the separate thing here, I can do here also. So just it is reducing the lambda expression and the streams concept. It is reducing the number of lines of code. Okay. Now another case is I want sorting on multiple fields. Okay. I want sorting. Earlier in all the examples what we have seen about sorting on one field, because here it is sorting based on employee ID, here it is sorting based on employee name, and here it is sorting based on age. Now I want sorting based on two different fields. Okay, let's see that how we can sort based on multiple fields. That one, say for example, I have a tree set here. Now this one, for example, I'm not passing this one. So this is the default sorting order. Okay, so I'm not passing anything. That means this is the default sorting order. Now to the set object dot comparator dot set object dot okay, assume that we have some default comparator, then comparing with other comparator. So now what I want to compare I want compare the same thing. I want compare with this one. I want again another comparison. Again another comparison. What happened here? Okay, wait. So this one. One second. There is so this comparator. Then comparing. This is started here and ending here, and this one is here. No, that is correct one. Then what is missing here? Write this. Okay. Add an argument to. Okay, I'm passing an argument. This is a comparator. Okay, so the same comparator I am passing here. Okay, for now, I mean, let's see. Maybe something is missing. For now, but let's see there. Okay. So in previous cases, what we are doing, we are uh, we are comparing with one field. Okay. Now here, what we are doing, we are comparing with we are sorting multiple times on the same tree set. Of course, I mean we are already given we all in all the cases we have given employee name. Okay, instead of that, for example, if I take multiple things like employee name, or let me do that. If I take another class, mm, what is that we can give? Say for example, manager. Okay, this one will say like manager name, first name, manager last name, department. Okay. Now I'll implement with parable. Okay, so now I'll just do the default. So for now, I'll just say like manager first name, and this is the default behavior. What is this? Okay, this is a string, so we'll just say like cannot convert from integer to boolean. Okay. Yeah, 1 second. Let me. I think one is fine. Let me. I mean, you can write any condition, but for now, I'm just writing like that. If the positive result greater than equals to 1, return +1. So, I mean, it's the same condition, but let's see here. So now instead of employees, what I'll do, did I anywhere else I have added? So instead of that one, I'll take so one comparison I'm doing with first name, and the next comparison I'm doing with last name. And another comparison I'm doing with department. Okay, so actually, yeah, this is not the this. Let me take another tree set. Example, finance department. So now what it is doing, if I give the same thing like this, so for example, again I'll give same name, but some, see, finance department, what I'll do, I'll say some construction department. Again to the same thing, I'll say yeah, and again I'll say like some fire department. Okay, but now what I'm doing, trying to I'm trying to uh, do the comparison multiple times. First, search it by compare it by first name, and on that result, if is what is this then comparing means? Where is that? Okay, so then comparing means first, okay, do the comparison based on the first name. On that result, do the comparison with the last name. On that result, do the comparison with the department. If you don't have this kind of lambda expression, if you want to write our own custom sorting order, then what we need to do? We need to create multiple classes like this, right? And we need to pass that every time. For first time we'll get one result, and that result we need to again pass to the second result. That again we need to pass to the second result. So like that, we need to explicitly write different methods for different comparisons, and finally you'll get the result. So instead of that, for us, we no need to write those different methods. Just create your custom defined sorting like this and pass it like this. So it'll reduce the code, and it'll have more clarity on what we are doing. Okay. So yeah, so that is what about comparable and comparator and how we are using in Treeset. So this is actually you need to practice a lot on these topics, because see, while explaining itself it is taking so much time, and there are different scenarios in it. You guys need to practice it and see how it is working with different scenarios. Okay. Yeah.
Okay,
In
sir.
the next session, we'll see some more classes and interfaces in collection.
Okay, sir.
Yeah. Thank you.
Thank you, sir. Bye, sir.
Thank you, sir.